Chapter 1: Introduction to AI in Medicine. Overview of AI and its history in medicine. Key concepts and terminology. Benefits and challenges of AI in healthcare. Overview of AI and its history in medicine. Artificial intelligence, AI, is the development of computer systems that can perform tasks usually requiring human intelligence, such as visual perception, speech recognition, decision making, and language translation. History in medicine, 1950s, 1960s. AI concepts began to emerge. Early efforts were focused on developing algorithms that could simulate human reasoning. 1970s, 1980s. AI systems like mycin were developed to help diagnose bacterial infections. These early systems used rule-based approaches. 1990s, 2000s. AI research expanded with more sophisticated algorithms and increased computing power. IBM's Deep Blue defeated chess champion Garry Kasparov, showcasing AI's potential. 2010s present. AI saw a significant boost with the advent of machine learning and deep learning. AI began to be applied in various medical fields, such as diagnostics, personalized medicine, and predictive analytics. Key concepts and terminology: artificial intelligence, AI. The simulation of human intelligence processes by machines, especially computer systems. Machine learning, ML. A subset of AI that involves the use of algorithms and statistical models to enable computers to improve at tasks with experience. Deep learning, DL. A subset of ML involving neural networks with many layers, enabling the analysis of complex patterns in large datasets. Neural networks. A series of algorithms that attempt to recognize underlying relationships in a set of data through a process that mimics the way the human brain operates. Supervised learning. A type of ML where the model is trained on labeled data, meaning the output is known for each input. Unsupervised learning, a type of ML where the model tries to find patterns in data without pre-existing labels. Natural language processing, NLP, a field of AI focused on the interaction between computers and human natural languages, enabling computers to understand and respond to human text or speech. Predictive analytics, using statistical techniques and AI to analyze historical data to make predictions about future events. Benefits and challenges of AI in healthcare. Improved diagnostic accuracy. AI can analyze medical data and images with high precision, reducing human error. Personalized medicine. AI can tailor treatments based on individual patient data, leading to better outcomes. Efficiency and cost reduction. AI can automate routine tasks, freeing up healthcare professionals to focus on more complex cases. Predictive analytics. AI can predict disease outbreaks and patient outcomes, allowing for proactive healthcare measures. Enhanced patient monitoring. AI-powered devices can continuously monitor patients' vital signs and provide real-time alerts to healthcare providers. Challenges: data privacy and security. Handling sensitive medical data requires strict privacy and security measures. Bias and fairness. AI models can inherit biases present in the training data, leading to unfair treatment recommendations. Integration with existing systems. Incorporating AI into existing healthcare systems can be complex and costly. Regulatory and ethical issues. The use of AI in healthcare raises questions about accountability, transparency, and ethical decision-making. Lack of human touch. Over-reliance on AI could lead to a decrease in human interaction and empathy in patient care. By understanding these fundamental aspects, medical professionals can better appreciate the role of AI in transforming healthcare and improving patient outcomes.